Are we live? Good afternoon, everyone. Lots of people here already. How exciting! So, yesterday we did some unboxing and some testing. Well, we printed a benchy. I've since printed the speed benchy, the speedboat benchy, the gripper thing, the gripper housing thing, this materially bendy thing, this thing, and this puzzle thing, which I've not put together into a puzzle. Hello, 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 Rushmere. Hello, James. Hope you're good. Hopefully everything's working fine. So the plan for today is to basically disassemble this printer as much as possible. I'm just noticing some greasy finger marks on my print bed already. Now, the original plan, as of about 10 minutes ago, was to just completely wing it. Just like I did with the Prusa Mini quite a little while ago, just start pulling screws out and see how far I get, just so we can kind of inspect electronics and see what motors and stuff they're using, because everything's kind of quite hidden from here. So it'd be nice to kind of take all the panels off and see what's inside. Obviously, I don't want to break it, but I do want to interrogate it. So I'm not like, I'm not trying to get information out. Well, I suppose we are trying to get information. Maybe it is an interrogation. Anyway, I've just found out that they have a maintenance manual. Because, I mean, that makes sense, doesn't it? I saw a lot of reviews yesterday and a lot of people obviously sort of commenting on open source versus closed source and I can't make my parts and how do I do repairs and that kind of stuff. I was like, well, let's find out. Can we do repairs? Maybe we could print these parts, even if they're injection molded by default. I mean, obviously a lot of things are going to be like non-standard parts, so we won't be able to do much about those. But maybe there is some things that we can replace on this printer. Maybe we can do maintenance quite easily, even if we do have to buy the parts rather than make them ourselves or just buy off-the-shelf stuff. So, I think in the title I put both of these things, or did I just put one? I'm not sure I'm going to have time to do both of them. I only got about an hour and a half before I get quite uncomfortable, so we shall do as much as we can do. I think this pulls off from here. Or maybe it doesn't. I saw on Sam Prentice's video, he managed to take this bit off. Hey! Don't know if you're meant to do that. But I don't see another quick way to detach the AMS from the printer. So that's the method we're going with. And that leaves that spring. So I've got this tray, which I actually printed on the X1 Carbon a little while ago. And that's going to hopefully store all the screws and stuff as we go so that I don't lose things. As I said, I don't want to break this machine. That is not the intention at all. I just want to see what's inside. So we're going to move the AMS to the side, just out of the way. That's not what we're going to be dealing with today. Oh dear. Yeah, so check the link in the description and you should find the maintenance manual. See if I can share it. Hang on a second. Doopy doopy doo. Hey! Okay. So I'll zoom in a bit so hopefully you can see stuff a little bit better. Oh, let's not go that far. So the BambuLab wiki, the link is below. I wasn't really trying to show this off particularly, but there's obviously a bunch of information here for other printers too. And it's good that it's available kind of day zero. So there's installation and disassembly information in here. Should you need to do any maintenance? There's even information on all the screws, which is, you know, actually, speaking of open source, like this is literally a technical drawing for the screw. This is not an open source machine, but this is a very good detailed level of information. I don't think there's technical drawing for like the actual machine plates and stuff, but at least if you need different screws, it's kind of available. Not perfect, I know, but here we go. This is where we're at. So I think this is probably a reasonable place to start. This is just say disassembly guide. So, oh, no, sorry, back down here. There we go. So we should just be able to kind of follow this, and this will probably reveal a fair amount of information. I think I'm going to have to zoom out to be able to see all the pictures. But this looks like quite a good start. So I'm going to get going with that, I think. Right, let's get going. So everything is powered off. It's not plugged in. It's switched off. We're reasonably safe. It's stopped printing a little while ago, so it's not hot. We're good to go and start the disassembly. So the first thing is these two screws here. We do have to try to be a little bit careful of things, but at the same time, I don't want to take days to do this. Hello, Jan. Okay, so there's a lot of screws. Hopefully they're not like weird types and sizes. What I'd like to see here is all these screws being identical. Well, at the moment, unfortunately, they're self-tapping screws, which is, it's okay. You'd be surprised at how many times you can, oh no, not those two. But how many times you can put a self-tapping screw in and out before it actually messes up the plastic, as long as you're a little bit careful. Machine screws into like threaded inserts might have been nicer, but probably would have also made it more expensive. So, you know. All of these screws so far are the same. These two for this were a little bit different, but all the ones around the sides have been the same. Hopefully in here we'll be able to see things like a power supply and the control board and things like that. I don't think, well, from the videos I've seen, nobody's really looked at that stuff so far, so I'm keen to take a little bit of a look. Cross-threading is free Loctite. I like that. Okay. Remove 14 screws, then pull and stretch the nylon ties to loosen the base plate. So we should be able to pull this out sideways, it kind of says. Wow, we kind of pull that out. Okay. That's kind of a clip. That's interesting. It's actually like a clip. So the putting the screw in also tightens the little bracket. Nylon ties. I don't know what it means by nylon ties. Oh. Okay, well that's that off. Interestingly, two of the feet just go straight through. So some of the feet are attached to this. So this is obviously an injection molded base plate. You got two of the feet coming straight through on this side. So this is like a big rail which is supporting the Y-axis linear rail. And then we've got a bunch of grills across the power supply. Another grill over here where you've got a fan, and this looks like the main control board. There's a little rubber thing here. I'm not sure quite what that's aligning with. It's aligning with this. I don't know if when the lead screw or something comes down to the bottom. I have no idea what this is. It's kind of part of this foot. Don't know what it does. But this is already quite interesting. Yep. Can I get a... Whoa, that's flexible. To point it up, it needs to be kind of this angle, unfortunately. Unfortunately, they're not LDO stepper motors, but, you know, you can't win everything. These are obviously stepper drivers. The power supply is a Morn Sun LM150, so it's a 24 volt, 6.5 amp. Obviously your mains coming in across here. Again, very strange how they've done integrated mains cable. You've got your switch here, which actually switches the mains, which is interesting. It actually looks like it's kind of damaged here. Presumably that's whatever tool they're using to press this in is maybe causing a bit of damage. Obviously you've got your screen down the front here. This looks like connections up towards... God, there's so much stuff in here. It looks like this is your antenna, presumably for the Wi-Fi. Looks like this is the power input. This is your main board. So the main board actually goes all the way along here. It makes it quite long, but it's quite slim. Hello, Lars. It's not a ton of power. And remember the bed is only up to 80C. I don't know what the bed power rating is. I assume it's 150 watts, is it? I mean, LM150 sounds like 150 watts. What's 24 times 6.5? I can't do maths today. 156, yeah. Right. We're going full disassembly. We're just following the disassembly guide. So, second screen here. You can see step 1 was this, and then step 2 is disconnect the cable ties. Use wire cutters to cut the zip ties, 2 screws, and USB cable, camera cable, X motor cable from the main board. So we're going to do that and see where we get to. So it looks like this one here. Again, the nice thing about having a guide obviously is I can do it in reverse and put everything back with hopefully not too much problem. I quite like the colours of the wires because they're 4 different colours, but they're all in grayscale. So you've got a black, a dark grey, light grey and white. Adds a nice style. And of course it's good that they've got the right colours for the mains wiring as well. Well, I've not checked that it's wired correctly, but I'm pretty sure it will be. You've got green, yellow for earth, and then you've got your blue and your brown. Brown, obviously live, blue, neutral. Anyway, what was I doing? Removing screws. Doesn't say exactly what screws you need, what screwdriver. So we're down to 1.5. So we used a 2mm hex Allen key up to now, but this bit needs 1.5. So there's just a small metal clip over this, which we obviously need to be careful not to lose. You can see just a clip like that. And that apparently, oh, blimey, that is the whole, that is crazy. It's actually a USB-C connector. Wow, that's the craziest USB-C connector I have ever seen. So we got JST-XH, 2.54mm pitch, and a small locking connector for the other thing. The this is like camera. See if I can get you a close up of this. So this is the wire, obviously, that comes out the side, which connects to the head. So obviously that's where you've got your X motor, your camera, and this USB will be whatever they're using to connect to the tool head. This is the cable that connects to the main board. So that is a USB-C connection. So that's what they're using to connect to the tool head. But obviously with this kind of strange housing, and then it's nicely connected down. You've got this purpose-made mount, which keeps everything nicely in place, and that's the metal clamp which goes onto it, and presumably that contacts this metal housing, which contacts to the ground on the board and keeps everything nicely connected. So that's pretty cool. Fairly easy to do that, and that's got your whole tool head unplugged. The next thing it says to do, well, you can do, obviously this is not something you should necessarily do when you get your printer. Oh, this one says actually an instruction of the size tool. Use H2.0 hex wrench to remove 3 screws B. Remove the fireproof cover. Fireproof cover. Use pliers to remove the 2 terminal insulating rubber sleeves. So you got this fireproof cover and this here. Heyo! Blimey, we're up to 84 people. Don't forget to like and share, because reasons. Hello, 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 hello. Lots of new people today. This is very exciting. So it looks like 3 screws for this. Are these the same? Yes, this looks like the same as the other screws, which is nice. Good design practice to use as few different types of screws as possible. It's great for every part of your design process to use as few different things as possible. So apparently this is a fireproof cover. Presumably that's if any of these come loose and start to create a lot of heat, then everything is contained within this fireproof zone to prevent heat damage to other things. Obviously, I'm not going to be testing that, but that appears to be its primary function. So I think this would now, just so you know, this is completely unplugged. Nothing is plugged in, nothing is connected, it's all turned off. Just in case you were wondering. Should I short the output? Is that generally a wise thing? I never remember. Short the output using some high voltage rated tools. These are rated for 1000 volts, so we're just going to short the output just to make sure there's nothing going to cause us problems there. And then use pliers. Oh, we can use these high voltage rated pliers and pull these things out. So we've got red there and black there. That's your low voltage, your 24 volts to your main board down here. So this is your signal wire to the bed. Ah, that's probably bed thermistor. Hang on, no, we've gone somewhere else. Hold on a minute. That's the bed output. Oh, we removed the heated bed. So it looks like the power supply is actually soldered. Can you see that? Zoom in, zoom in. I want to zoom in more than this. I need like a an extra zoomed scene. Right. I'm going to see you on that screen just for a second. While I try and create a cropped version of my normal scene so I can zoom you in just by there you go. How about this? Boom. Hopefully that's still reasonably clear. I think the signal from the camera is in 4K, so should still have plenty of detail. Here you can see down here. So these wires are soldered directly to here, but they're obviously screwed at the power supply end, so they are still removable, but permanently connected on one side. Yes, there was a connection. This fireproof cover over the power connection. Extreme close-up, yes. Any UL standard on the power supply? C doesn't mean much, to be honest. Well, these are the things on the power supply. I don't think you'll see much more than that. Now that we've got our extreme close-up view. Then we've got the less extreme close-up view. And then we've got the zoomed out view. I can probably then just go straight to zoomed. So, no. Use a wrench to unlock the plug and unplug the two heat bed power cords at the same time. Disconnect the, hang on. Use pliers to remove the two terminal. Oh, just remove the plug, the sleeves, and then do those. Disconnect the connection of the heat bed signal cable from the main board. Remove one screw A and loosen the heat bed cable from the cable buckle. So what we should be able to do, should we just do this? Is that zoomed in enough? So we've got this here. I think that's just going to be the thermistor. It says signal cable, but I'm pretty sure this will be just power output as PWM, and this will be temperature. And then we've got a single connection here. That is a different screw. It's a bit shorter than the others. And we've obviously got tape. Not a huge fan of using tape, but this stuff is generally quite repeatable, I think. Why can I not get that off? Oh, okay. This clip does both things. So, and that's our wire out for the heater bed. Place the printer upright and remove 3 screws that secure the heater bed. So, okay, flip this back around. As you might expect, the printer does become much more flimsy once you take the base off. A lot of this kind of structural sides require, see, it becomes quite bendy, which is why you need this fully enclosed stuff to hold it all nice and tight. That's not a bad thing, by the way. That's just the way design and assembly typically works. Remove 3 screws that secure the heat bed. Ow! Two. Okay, there's obviously some extra things. So that's it says 3 screws that secure the heated bed. Press down on the heated bed with your hand and remove 4 leveling screws. Take off the heat bed along with the adjustment springs. So there are additional ones. These typical screws which we'd expect to find. So I'm going to have to do some re-leveling of the bed, maybe. Before I lose them, let's get these tidied away. 89 people. Lovely jubbly. Don't forget to like it. Hit that like button. Go now. Press it. Press down the heated bed. Remove the screws. Take off the heat bed along with the adjustment springs. So this should just lift off. Yes. So we got. So these are the screws that hold the bed in. So that's interesting and to do with leveling. So you got 4 screws for leveling, and then once it's leveled, you lock in the corner ones, and then your leveling screws kind of do nothing, which is interesting. Kind of cool, actually. So, oh, sorry, I've done all that with the. Is that the zip? God, that's the zoom. Okay, well, let's bring this in a little bit more, and then we go to zoom. So you can see it's a PCB type heater here. So to me, this looks like aluminium PCB construction, and then you've got this foam, which I think is just going to be there for insulation, because they're quite low power. The less heat you waste, the more you can obviously heat the bed. This would be thermistor right in the middle, got with some squishy goop under it to thermally couple it to the bed. Typically, they're actually better not quite in the middle, I think, because that would go to be the hottest place. So you can have your center a little bit hotter and then have the temperature sensor out here, and then more of the bed is at the temperature you want. But yeah, swings and roundabouts. Interestingly, obviously only 3 screws. I'm guessing they just have omitted this one here because you've got the bed connector, you just can't get access to the end the same as the others. So instead of having something weird and different, they've just not put one here. Ultimately, they're not going to do a lot, I suppose. Like, you could probably run it without touching them. But my guess is, because it does the vibration for compensation, if you run that a lot, that's going to loosen all of your screws. So by having these additional screws here to hold the bed leveling correct, it's not going to change every time you do that vibration thing, because I think that vibration a lot of the time would change the leveling of the bed. It'll loosen off some of the screws. So by adding in these, fixes everything down. Looks like this stuff on the corners is all going to be replaceable as well. Let's give it a little test just to see if we can unscrew these screws. It looks like we probably can. There's too much chat going on in chat. I don't know what's going on in there. Hopefully everything's fine. So yeah, I mean, if you needed to replace that, I mean, probably could. I mean, that part could be designed to work with ABS, like no problem. Oh, don't over tighten things. So the whole bed brush looks like it can be removed. I know there's a replacement rubber bit, but that bracket looks removable too. Looks like this is all going to be removable as well. That's all screwed together. Let's give it a go. Hmm. There, we've got a dodgy screw. One litre Peter, welcome to members. Thank you for joining. So that's cable cover. Do we need to remove more? We do. There you go. They're all screwed on as well. That's actually quite nice, the fact that this lot's screwed. So that makes this cable quite replaceable without a soldering iron. So, I mean, the bed stuff's all glued together, but I think you would have to kind of expect that. That's quite typical. But the fact that the wires are all kind of on separately, you've got the thermistor. This thermistor from here to here is all soldered in, glued onto here and glued onto here. So this is not going to be very easy to replace, although you could and just tape it on the top of this. But yeah, the fact that because this cable will probably break eventually, so hopefully they'll have a spare one of that you can buy or make yourself even. It doesn't look that difficult. But the fact that it screws on, that's kind of cool. I like that. Hopefully we can get this back together without breaking anything. Yes, we got the VZ bot to work with. Yeah, there's so many things to do. This is the problem. I don't have infinite time. Come on. Just double check these are all nice and tight. Don't need stuff coming loose. Cool. That's the bed. Looks like we got some springs. They're all pretty tightly fitted there. Right. For my next trick, remove the USB cable, camera, and X motor cover. Remove the filament tube and USB cable from the filament tube clamp. Press the fitting on the filament tube to disconnect it, and then remove the PTFE connector. Okay, I don't think those are connected to the clamp tube thing anyway. I think it means this. Apply force from below the motor cover lid, front lid to remove it. Yeah. Hey, that's kind of easy. Look at that. Right, let's show you inside. Inside things. So kind of what you'd expect, I suppose. You can see where the cable comes up through this little ceiling thing, kind of grommetty thing. You've got the pulley attached to the stepper motor, which you can see screwed inside. Oh. And you've got the camera down here with the built-in light and the privacy filter thing doobly on here as well. Just a big plastic casing. So pretty much what you'd expect in there, I think. Nothing particularly fancy, but all looks pretty nice. I don't know how you get this cable doobly out. I wonder if it says in the next part of the instructions. Remove the cable buckle left on the cables. Tear off the tape at the end. Pull the camera connection. Okay, we probably don't want to do that too much. So we can disconnect the camera. And I don't quite understand how this connection works. It sort of implies that you push it in. Oh, and then pull it out. Insert an Allen wrench to the cable clamp and pry it out. So there you go, there's your cables. If you wanted to start modifying, not modifying really, but changing, replacing those. Oh, camera. Cables all in the braid. So they're in there separately. You've got your motor, you've got your USB, and you've got your camera. With a bit of braid down to the cables at the end. So that's all that part. That easily goes back in there. So I guess that kind of goes on there. That goes on there, and that just kind of presses in. Let's check. Pull that, put that out of there, cut that, open that. Remove the magnetic ring pull, pull out the USB cable. Remove screw F2G and take off the X motor cover assembly. So we're going to, I think, take this out to here. I don't know how much we're going to be able to continue to assemble. I don't really want to be redoing all this like cable braid stuff because fishing wires all through that can be a bit of a pain. But we're going to continue some disassembly up here. And what I might do is switch tool because it's a bit deeper. 2.5, 2. I think if someone spent a lot of time, you could make 3D printable versions of all these plastic parts, if you were so inclined. So that is not a 2GT belt. Oh, Lars gifted 5 memberships. Thank you. Very generous. Good stuff. Super doopy. Right. Yeah, this looks like a different belt. Have I got a... It is definitely a different belt. How can we measure it? I'm going to get a thing. Back in a second. You can't get gifted memberships. It's not because you're a moderator, is it? Tripod's Garage. Good afternoon. The pitch looks like 1.5 millimeters. I'm sure that can't be a custom belt, but I've not seen it before on a 3D printer. I wonder if... The Project R3D team. Thank you very much for the $100. That's super kind. I'm glad to be back. I'm not fully back yet, but I'm getting there, and it's good to be able to do stuff. Oh, yeah. Thank you, James. So this is what we've got in here. You want zoom? I'll give you zoom. Maximum zoom. Oh. Oh. So yeah, I don't have a oh, I might be able to grab a 2GT belt so you can compare visually. I used to have some close by. Aha, I see one poking out. Here we go. Here's a short piece of belt. Quite a different profile. The 2 millimeter belt looks positively massive next to that one. Oh, I've just pinged a spring. Oh no, where's the spring gone? So it looks like those are not as fixed on as I thought they were. Oh no, it looks like they are glued. I just happened to unglue it by accident. I wouldn't say the square profile. The profile of the teeth looks very similar. Is that... I don't know. I think we're fascinated enough with that now. It's time to move on. Press the direction of the arrow to unlock the camera. Remove the camera from the X motor cover. So the camera just comes out? Sort of. Does it? There you go. So if you need to replace the camera, that's the kind of camera unit that you could replace. Again, that you can't really make one of these from scratch, but the fact that you can just replace that, and you don't have to get like the whole end module or the whole axis module or something stupid if your camera breaks, that's quite nice. As long as they actually provide these as spares. I don't know exactly what their spares program is going to look like, but I'm hoping, given that they've designed it such that it can be removed like that, it would seem sensible that they actually provide some method of actually doing that replacement. So remove the camera, we can move the motor. I think hopefully we can remove the X-axis assembly without removing... Oh, sod it, let's just remove the motor. Because it's got the pulley tension and whatever. I don't know where tension is. Oh, I think it's this screw over here. So this motor is definitely a NEMA 17. I suspect the extruder may not be. The head looks too small to house a full NEMA 17 size motor. Sorry. So I've just done the 4 screws at the front. Somehow I assume this will come out. Oh, there's like this cable cover on the back. There's some little screws that we can remove to get this off completely. I might try and ask Bambu, or maybe if they watch this, it would be really nice, if possible, to make 3D printable versions of the plastic parts. I think that would be really awesome. Would it be necessary? Probably not. But it would be a nice gesture potentially in the event of like breaking things. I'm sure some of these parts, there are some like really small details that you're not going to be able to replicate on printed parts, but I don't know. So that's the X motor off. Yeah, the fan's underneath here, isn't it? Mental. So that's your really tiny belt. It's completely custom extrusion. This is a whole mounted like CNC block, which is pretty cool. So now we can go ahead and remove the X-axis assembly. So we've got... I mean, I'm hoping this is all going to be kind of jigged so that I can put it back together reasonably square. And that's when you know something's well engineered, when they've thought of not just the final function, but also the assembly and disassembly of the product as well. Starting to run out of places to put screws. So we do have to be careful now because we've got our linear rail that could just fall off the end of here. I wonder if they've determined that a smaller pitch belt helps reduce some of the artifacts in the print. It's possible. This is the fan, I don't know. Yes, so this is the back of the fan, and the top of the fan is like up here. It's insane. And then the duct blower. Is this a sensor? I just want to disassemble all the things. How long have we been going? 50 minutes. So this is just a big old chungus block on here with this absolutely massive rail. that going to let us scooch the block out the end? Look at the size of that. It's absolutely huge, this. For such a small printer. It's a pretty massive rail. I'm not following instructions. Oh, we can take this off as well. And take this off with these two screws here. So it's die cast. It's a die cast block that's then machined for a finish. So die cast, well, I'm pretty sure it's die cast from my limited die casting experience. Die casting is basically injection molding, but with aluminium. So you have a mold that will make this, and then you can see here you've got like machined lines from where that tool's been spinning, and it leaves a kind of trail. So with with die cast, you get a pretty reasonable finish, but if you want a precision surface, then you'll typically machine whatever those important surfaces are to whatever final tolerance you need. And that is just a massive block. That's so cool. And then the lead screw, can you see? The lead screw is all hidden inside here. It's all blurry. Can you focus, please? Focus, please. There you go. You can see now. This is the lead screw, all in there. Okay, according to instructions, we've disassembled that. So now we can remove the y-axis linear rail. I'm just wondering if I have more trays. Oh dear. This is a few extra trays. I'm just concerned that I don't remember things. That's that whole assembly. I can go over there. So now we're down to this is our printer. There's not much printer left now. I suppose there's quite a lot of printer left. So the next thing we do is remove the y-axis rail. So there's these two screws here, which apparently we just whiz out like this. And take this bracket out. Well, that's clearly attached to the belt below. Have I done that right? Push the heat bed bracket backward to expose the two screws on the connecting plate. Two screws on the connecting plate. I'm confused. Oh, so here, you can't pull it up. Apparently here. Oh, I think it's here. Oh, shoot the bed. I'm not sure, as much as I've enjoyed the design process so far, I'm not sure I'm a big fan of this bit. Well, I was hoping to do the assembly and disassembly all in one stream, but you're right. The reassembly might be tomorrow. I think this process is probably easier without the studio lights. It makes it quite difficult to see because of the contrast difference. There we go. So once you remove those screws, this plate pulls out the top. Whew. Steel rollers. I can't actually see. I assume it's steel rollers, but they're covered by these plates. They're very covered from all angles. So I have no idea. Take these screws off. Is this the ones? Yep. Whoa, hello. Oops, don't touch. Remove 2 screws and take off the y-axis recover. Remove 4 screws M and remove the y-axis linear rail. Oh, Jesus. These are tight boys, these ones. 2, 3, 4. This should just lift off. Ta-da! Well, I bet you've not seen this on any other YouTube channel so far. Here we go. Now you can see the underside. So yes, in answer to your question, you can see 4 bearings, steel rollers attaching to that rail, which looks like that. Pretty sweet. We only have 62 likes and 100 people. Let's try and make it to 100 likes. I've not had 100 likes on a stream whilst live for a while. That would make my day. Make my day, people. Make it happen. That's right. If you want to just watch, just watch. So that's that. This is pretty good disassembly guide. Oh, is that the end of the disassembly guide? Okay, that seems to be the end of the disassembly. And then it's just the same thing in reverse to put it all back together. Sorry, second screen. Yeah, so this is where we just got to remove this. And there's install to put everything back. But we're not going to do that, are we? We're not going to do that. We're going to disassemble more because reasons. I want some more information on this boy. Huh. It looks like at some point they had intended to put a bearing in the top of here. So you can see how this is shaped. with the screw holes here. I bet they were going to have a flange bearing sitting in there to hold this lead screw in a specific position, but found that actually that makes things more difficult and can result in banding in particular circumstances. A lot of the time, it can be easier just to leave the lead screw open at one end. This looks like a kind of fancy lead screw, actually. Let's investigate. $17 likes short. Let's make it. We can make it to 100. There's 100 people. We can make it to 100. There's 112 people. 16 more. There's a hole here, but I don't know how to access. It's interesting. Look, they've got. So this part here is all plastic, but you've got this whole strong beam, which is obviously what the rail is screwed into, and then this is all solid across here, which mounts directly into this. So although a lot of the printer externally looks like plastic and would be wobbly, all the structural parts, all this, and this, all connected by really solid aluminium. I was going to say steel, but I don't think it's heavy enough to be steel. This, I don't know, this might be. Just because, so typically you would not screw directly into aluminium because the threads pull out quite easily because it's a relatively weak material, especially obviously when you're using steel screws, which is why I think this is steel. But this I think is aluminium, especially since it's extrusion as well. Whereas this just looks like a piece of box. Oh no, that's folded sheet metal. It's pretty cool though. Look how tight the integration is. There's just no extra space for anything. Every tiny little space is used. I love that. No waste. So we've got some stuff here we could undo. I do not know which piece will come off next. I'm starting to store the screws with the parts that came with them in the hope that will help me get things back together. I hope this linear rail is fairly stiff, which is good, so I don't think we're going to have a problem there. I might try and undo this. No, there we go. The body, oh. There's a facade. This facade, yes, is plastic, but as I mentioned just now, this is obviously all metal, this is aluminium, this is aluminium construction along here, and then I think this is steel. Well, some combination of strong metallic components. So the core is all metallic, which is why it feels like a really robust, sturdy machine. But you've just got this big plastic shrouding over the top to make it look pretty. But it's so compact, that's what's really impressive to me. So this cover comes off the back, and then you have access to not a lot. Some screws. I don't have any guide now. I'm completely without a guide, so. Oh, did we make it to 100? Yes! 102! Thank you so much. I'll be here all week. Well, no, I won't. But I've been here for a couple of days this week, and that counts. Is that going to allow the... No, it's not enough. Aha. Is this wise? I don't think this is wise. There's got to be a better way to get this out. Well, I think we've worked out why they don't provide more instructions on disassembling it further, because it gets rather complicated. I want to get this out. The best thing might be use some tool. Now, which way do I need to turn this? I don't want to access the coupler. Yeah, I can get the screws in here, but there's bearings and stuff in here. So if I take this out and pull the lead screw out, it could be really difficult to get that stuff back in. Well, I'm sure it would be funny for everyone to watch me not be able to reassemble the printer. I do want to put it back together. Oh, come on. So close. I don't know how I can't unscrew this. Aha! 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 I see some screws. Is this the key? I don't know where that one's come from. Oh, that's the top one there. That's the second one here. No. I thought that was going to maybe let me pull the motor out the bottom with the lead screw attached, but it's not going to let me. I'm not sure what's holding this motor in. There's always 4 corner screws, so I feel like there's one on this plastic part that can't get to. That's screwed into there. That's just plastic. That's just attached to there. I feel like this plastic part, this whole motor part should press out now. And it's definitely not. We're not going to be able to get this out, I don't think. Not without getting grease all over my hand, which I also don't want to do. Have I got somewhere to clean my hands? Yes, I was thinking if I can't do this bit, then we'll move on and have a look at the mainboard. That's certainly a piece that I'd like to look at, and I think I'm starting to give up on this part. I think it might be beyond what I'm willing to risk. Maybe it's... Maybe I have to remove the coupling to get the... Surely the coupling is not holding it in. That would be strange. I don't think the motor's held in by anything. That bearing's going through there, connecting there. It's going there, directly down to there. Ah, there's screws going here. Yeah, I might have to remove this coupling. This feels risky, but I'm going to do it. So that's allowed that to come out. Oh no, how's it still not coming out? You mother Hubbard. Maybe it's a clip, maybe it just needs a push. Yes, victory! So das ist lead screw assembly. So it is a kind of funky... Right. So this is... So this is obviously non-standard. How many starts is it? It looks like a 4-start, 8mm pitch, which is fairly standard. And then this is a custom die cast bracket, definitely aluminium. This is obviously the brass lead screw nut with absolutely buckets of lubricant on it. You've got a bearing pressed into here. You've got a bit of a strange assembly here. There's 2 bearings, it looks like. Oh no, 1. So you've got 1 flange bearing on the bottom, a bushing, and then a machined end on the lead screw. Well, metal parts is the right way to do it. When you've got large quantity, die cast is a really effective process. This is not going to be very easy to reassemble. But there you go, there's the lead screw assembly. Right, let's put that to one side. Unplug this. And we can't quite unplug that motor because the fan is in the way. Let's try and get to this electronics board now. That's part of the bed. Put it there. Clean my hands up a little bit. The motors are called just stepping motor. There's someone want to write down the model number? BJ42D15-26V102. And there's another line of AD081E D00B 20301. Now, I don't know if they're all the same. No, they're not. This is different again. This is BJ42D22 42V02. Then AD081AC00B 20201. There you go. Model numbers for the stepper motors. Not sure which data out of that is important though. No, where's my screwdriver gone? I've seemed to have lost my screwdriver. There it is. So we've got a 5-volt DC fan, and that's that. Fan, Z motor. We've got the Y stepper motor over here. And a small cable. Is this a thermistor? It's going all the way down over here. Up to here. Over there. Is it a sensor? Is that a Y end stop? Eh? That's a... There's some funky weird electromagnet end stop doobly. Oh, it's like an inductive sensor or something. This is weird. Oh, that's just... Can you see this? Can you tell what it is yet? So this bit here, so these wires here connect to here on the motherboard. Sorry for the move around all over the place. So you've got 2 wires, just 2 next to your Y motor. It goes all the way down here, under here, and all the way up the side, all the way up here. And then it comes out up here. These 2 wires here, and then there's just this copper coil in here. And then you can see as this carriage comes along, There's like a little metal plate at the end of it. It just looks like a piece of foil, which then does the end stop. Looks quite cool. So don't know exactly what sensor it is. I thought they were using sensorless homing, but in that case it looks like, at least on that axis, not. Oh my goodness, that's a spring tension as well, I think. There's so much different in this machine to like every other printer. Right, let's get the control board out. I'm starting to wonder if I'm going to be able to get all this back together. I suspect what I've done so far may no longer be covered under warranty. Oh well, I think as a review unit you don't get any warranty anyway, but who cares? So that's your little IPS touchscreen panel. Just a small ribbon cable that goes into connector here. Lift it up to be able to insert and remove, and then click it down. And then you've got a small connector over here for your Wi-Fi antenna. Very easy to mess those up, so be very careful if you ever change that. There's a small chip here, so let's try and read what that says. I did have a light here somewhere. Might just have to use my phone. It's an ESP32-S3. It looks like that chip is handling the touchscreen display. There's also two little buttons. Two little buttons on here, don't know what they do. I'm not going to press them. Probably won't do anything while it's turned off, but better safe than sorry. Let's see if we can get the rest of the board out. And before we do that, we're going to need to take off the power. Is this one a... No. It's also a fork, but for some reason it's eaten by the screw. Another one here. I might not be able to do this much longer. ESP32 would be Wi-Fi. Well, yeah, I was thinking something down here would be just Wi-Fi, but the traces and the way it's kind of got this signal separation makes it look like it's not. All the traces are heading towards the display. Here we go. Right, let's move this doohickey out of the way. Try and get you some decent close-up. Just put everything in a bag and sell it. Oh, that's such a good idea. Well, it's a horrible idea. It's nasty, but it's quite funny. So this is the front of the board. Let's see if I can sit it down. Oh, it kind of sits like that. Hopefully YouTube quality is not going to completely destroy it. So this heatsink here is actually not connected to anything. Under here is just the SD card slot. So that's a bit weird. I guess this is just part of this cooling system and cools that together. That's very strange, but sure. This is obviously your 3 stepper motors for X, Y, and Z. You don't have an E here because obviously the extruder is driven by the daughter board, which is on the extruder head. Oh my gosh, we haven't even got to that. Oh, blimey. I don't know if I'm going to be able to check what the stepper drivers are. I'd really like to. I don't want to destroy my machine. On the back, you can see what is presumably the main chip. This is a Spintrol SPC2168APE SWN3WH2231. Mainboard version 6. It's actually N1 mainboard version 6. So what's an N1? Maybe they were going to call it an N1, and now it's the A1. Who knows? Or maybe they just have N for like an electronics assembly number. I don't know. Interestingly how they've kind of potted the underside of these connectors. Not sure quite why one would do that. I don't think it'd be readily available heatsink. This looks like it's designed specifically for this purpose. They've created this extrusion shape, and Bambu are planning to sell a lot of these printers. I can tell by the way it's made. Like, you would not die cast stuff if you were not planning to sell a lot of them. I'm pretty sure for die casting to be an effective method of manufacture, you need to be making well upwards of 10,000 units. I think. That might not be totally accurate. But if your batch isn't 10,000 pieces, then... Okay, it's just thermal paste. These do not look like standard stepper drivers. What the dickens is going on here? Maybe they are. Maybe they're not. I'm going to have to get some replacement thermal paste, I think, or ask Bambu very nicely if they'll send me some. Oh, golly. What a mess. I made a right nasty of that. Is there a better way? There must be a better way. It's going to need a bit of cleanup after this. Pretty sure it'll be non-conductive, but... Hopefully non-toxic too, because I think I've got it on my hands. Right. I don't know how this works. I don't know how you can drive. I'm not an expert when it comes to stepper driver electronics. But this is not like a stepper driver that I'm used to. A little bit of IPA. Where are these two tiny screws from at the heatsink? Right, let's see if I can work out what's going on here. So they're two chips, both the same. It says 88236 DD0 1D 1Y. AT8236 DD0 1D 1Y. They are motor driver ICs, according to JLC PCB and AT8236. Used in a dual configuration, apparently. Or they use one for each side. I don't know. I'm not going to be working that out now. The whole point was disassembly, not reverse engineering. So I'm sure if you want to work that out, you can work out how that works yourself. So we're at an hour and a half, and I think I've sufficiently torn down this machine as much as one would be reasonably expected to. I've made quite a mess. Oh no, the extruder. We have to do the extruder. Right. In which case I have to clean this. We're going to have to find some way to reattach this heatsink securely. I don't know if I have any more thermal paste. Come on, Adam. You must have some thermal paste somewhere. Aha. I mean, this is like PC thermal paste. I'm not sure it's quite the right thing. The viscosity is probably not ideal. Hello, Steve. Good to see you. Somebody mentioned yesterday in my live stream that you were using my live streams to help with your VZBot build, which sounds pretty cool if you were. Hopefully it was useful. Yeah, this is... Need more members. Gifted 10 more members. Steve, you didn't have to do that. Thank you so much. So many members. How many people get membership? Right, I'm going to put that to one side. I'm not sure that thermal paste is going to be sufficient. Before we do that, I might reattach the... No, I can't reattach the fan now because I have to attach the motor and that goes afterwards. Okie dokie. The extruder hot end. This should be the last thing. And then I think I've broken everything. So... This is again going to be a wing it and hope for the best scenario because I don't have any guide on how to disassemble it. Let's try and get this nice and close. It's all small things. Yay, I'm glad they were a little bit helpful. I had a really strange comment yesterday. I think it was through the shop. Someone was asking something. They were like, I really like... Well, no, they were like, your live streams are really dull. Like, they're really slow and boring until I need some information, and then they're a gold mine. I was like, okay, I'm sure that's meant to be a compliment. Like, they're shit until I realize I need them, and then they're amazing. I'm like, okay, thanks. Ah, there's a USB-C cable. That was not what I was expecting. But there you go. I guess I should have been expecting it, knowing that USB-C is on the other end. I'm really conscious that I'm going to lose this rail right off the end. Before we do anything else, I'm going to attach some zip ties to this to try and stop that happening. Where are my zip ties? There we go. Now we can disassemble, safe in the knowledge that we're not going to lose our linear rail balls. So this looks like this comes off the back rather easily, kind of. Ta-da! That's like all your information right there. I'm not sure what this big fat lump is. Is that just a... Ah, that's the like... Is that the Hotend connector or heater or thermistor or something? So that's a connector. And then we've got a connector down here. We've got some tiny little connectors in here. We've got a connector up here, connector down there. We've got another MCU. There's a ribbon cable. There's a lot going on in this tiny little package. So this is another spin troll, SPC1168 APE. It sounds similar to the last one. And then we've got loads of screws. I don't know if I should be disassembling from the front or from the back. This is such a detailed assembly. Normally I'm really not worried about disassembling things. I'm like, I trust that I'll be able to get it back again. But this time, I'm less confident. Just have to kind of trust that your brain just remembers stuff and just hope for the best. I mean, it's all kind of on video, but it's not quite always at the best angle. I used to have overhead camera, but it was just a webcam. I was so fed up with their NAF quality that I ended up just getting rid of it completely. Ah, so that's the ribbon cable. Let's make sure we take that out before we break it. So that's the tool board. Obviously there's a component that used to be here that now isn't. Maybe that was for testing or diagnoses or something else, or maybe they just weren't sure on what to use until nearer production, so they kept options or whatever. And that's the spin troll MCU that you can see on the top. And then here we got a dinky little stepper motor. It's absolutely tiny. Tiny little motor. Is a tiny little motor. Oh. Compare that to a NEMA 7. Oh, everything's connected. How about this one? There we go, NEMA 17. So I'm guessing that's a NEMA 14. That is an adorable little motor. Two screws here. This might just be for this little bracket. Oh, that's what the ribbon cable's connected to. Nice. So that's got the sensor on it. I think this is the filament sensor. God, this is so... So if we take a look in here, you can see this. It's only a single-sided PCB by the look of it. But presumably a very simple filament sensor. Oh my goodness, it's a whole like little lever. Oh my days. That's the PCB. This, oh my gosh. Oh my goodness, what is going on? I need some filament to see how this is going. Let's just grab a bit of this. I'm guessing it's going to be some type of magnetic sensor or something. So it's literally just a steel. This just looks like a very small piece of steel. It might be magnetic. We can sort of test, I suppose. What is... Yes, Hall effect. Oh, that is 2 parts. Yes. So you can see, on the arm here, the length of the arm from the pivot down is just probably steel or something, just standard metal. And then this tip here is separate to the body, and this is magnetic. So these little bits on here are, I'm pretty sure, Hall effect sensors, and these will sense the change in magnetic field as this moves in and out. So obviously you get no filament, filament, no filament, filament. Pretty fancy, pretty simple, cost effective, presumably. And it's not all glued together, like you can disassemble that. So that's pretty cool. Very nice. Let's keep disassembling until we break something. No, I'm not going to break anything. I'm being careful. I don't think we can do much from the back at the moment. I think it's onto disassembling from the front. Screws just going everywhere. Loads of people dropped away. When did they drop? 130 to 100 when I did something. Somebody didn't like something. 30 people just disappeared. Okay, never mind. So somebody asked, is this something to be able to... No. Is it to like manually drive in the case of a jam or something? It's not. It's not at all. It's barely attached. It's literally just an indicator. So it doesn't, the orientation or anything, you're not going to be able to apply any torque. It's just shows you that things are spinning when you might suspect they're not. Question is, what can I remove without breaking stuff? Maybe this fan assembly at the base. Maybe they finished work. They all have finished work and all left. No, it was like 10 or 15 minutes ago. Is there another screw somewhere? No. Yes, no, maybe. Must be, because I can't remove it. Aha. Secret screw. Oh, I can't reach it. secret screw in the back. This will be one I forget to put back later. Is that just... They've just custom designed the whole fan. It's a 4-pin fan as well. But that's not a fan in a housing. That is just the fan. That's the fan, I think. You take 3 screws out and it seems to make no difference. This looks like it's holding in this fan, but I can't see what else is holding it in. It's all very confusing. This looks like it's mounted with some high temperature plastic, so I'm assuming this is, yeah, this is like the heater core. The heater and thermostat assembly. It just goes down there. And there's 2 extra screws behind it. It's just screws upon screws upon screws. I was thinking it would just detach from the rail at some point, but that doesn't seem to have occurred. You know when I said very early on in the stream about using as few different screws as possible? Well, it seems like for the extruder, they've tried to use as many different screws as possible, which is not so good. Not so good at all. Oh, come on then. Okay, how many... Let's take bets, shall we? I don't know how we're going to record them anywhere. How many screws are going to be left over when I put it back together? Oh, that's just a protective thing for the cutty thing. Cutty bladey. Can you see that? Maybe this angle. See, the blade comes in here. That's the filament. I don't think that needs to come off. Don't think that unlocks any further things. You can kind of reference it to put it back together, this is true. But you've got to remember that the quality of the YouTube stream is pretty rubbish compared to what I'm seeing here. And these screws, all on stream, will just look like all black, shortish screws. It kind of can help a bit in terms of general process, but getting the right screw in the right place, still not an easy job. Oh, here we go. This has made a whole load of stuff fall apart. Oh, hello. Is this just a slidey bit? There's like a cable channel here with like a separate piece of plastic. Looks like it would either slide in or clip in. There we go. So there's little cable covers over the side to protect your little channels. You've got the hot end, fan, other more different, smaller fan. Holy balls, Batman, we've done it. We found the magic screws. Oh no, wrong size. Why do people keep saying they're not making money on it? I don't understand. Well, I do understand, but I don't know why people think they're suddenly just not going to make any money. I think people are just sort of wanting them to fail or something. I don't know. Are we dual rail? No. This is not connected to this rail anymore. But it also doesn't come off. Oh, I see. I'm just going to leave that like that. So basically the reason there's the belt tensioner kind of goes down into this channel a bit. So to take it off, because everything's kind of like this is entrapped all the way under here, you'd have to remove that. And I don't really want to take off the belt and change the tension on that or anything. So we're going to call that disassembled. Hopefully you're sufficiently satisfied that I've not said I'm doing something that I'm not doing. This is another weird sensory thing and I don't know what it is. Oh, this might be the eddy current sensor thing. So, I mean, there's nothing really in here. It's just the motor and the extruder. Yeah, I think I'll put it back together next stream. I don't know when that'll be. I mean, it'll probably have to be tomorrow, because otherwise I will forget. Maybe I do have to take this off. This part that I thought I didn't have to remove. what I'm going to do, just because there's an extruder now with some high tension spring that could ping off at any moment. Just putting on some safety glasses just in case. The place that it happens to spring to is my eyeballs, because that would be rather unfortunate. I am not sure how this comes apart anymore. I mean, I can try this, but this I'm sure is just extruder tension. That one just looks like it's holding that arm onto the back. Can anybody spot any sneaky screws? I mean, I guess I'll just try the two that I can see. That's the only thing to do, isn't it? So that's how you replace your little cutting blade. That would be actually quite simple. Because that face, once you take the cover off, is like immediately accessible. So you get there, undo that screw, that lever comes all the way out. There's your blade. Now how the absolute F does this come off? Ah, like so. Oh dear. Parts just went everywhere and I have no idea where. Oh no! Okay, I think I know. So we've got a spring. We've got this thing, which I think just goes in here. I think that's just where... I think the screw butts up against this thing. Or part of the... Yeah, part of that, I think. And then the screw pushes on the other end. And then that's your levers. That one will leave attached. That's your little motor. Adorable tiny little stepper motor. That's your model number. And that's the sensor that just goes in down there. And then you got the extruder, a couple of heatset inserts, nice to see. And then your extruder gear assembly thing. So you've got this what do you call it? Oh, I'm forgetting what it's called. Terrible. Terrible, terrible, terrible. The slanted gears. Helical? No. Looks like we got some filament stuck in the... God, that nail's long. Holy shit. Some little bits of plastic stuck in our gear teeth already. Blimey, Charlie. Look, this is the sensor. I think this is like a beacon sensor. If you look in the top here, you can see this kind of PCB, this kind of coil thing. You need a spudgerer. Don't know why. Oh, I think there are secrets. There are no secrets. We'll just leave that sticker off. I don't think we need it. Although it might protect that, which would probably be nice. But it's a bit late now. I've just folded it in half. Silly mate. Not getting much in terms of dividing this thing open, though. So yeah, I was right. This is literally just the fan. I'm not quite sure what this is. I think I'm going to end up breaking it trying to get it off. There doesn't seem to be anything. You know what? I think it was a thing, and now it isn't a thing. I think this was a hole for a cable, and something fitted in here. And then they were like, no, we're not going to use that. I reckon that was what was going on. Because otherwise it doesn't make sense. There's a whole feature here with just... I mean, tell me if I'm wrong, but I'm pretty sure this is just a piece of plastic. I mean, it's got some weird lines on it, which makes it look like it could be a thing. It suspiciously looks like a thing, but it doesn't connect to anything. Yeah, I reckon it was a beacon type sensor, and they decided not to go with it. Right, is there anything that we've not disassembled that somebody would like to see? Because I'm sure if somebody here would like to see it, somebody in the future would like to see it too. If you have any questions, now is probably the best time to ask. Because once it's reassembled, this shan't be happening again, probably ever. Oh, I got so far and now I've just dropped, found it, dropped a tiny screw. My fingers have turned to butter. Ah yes, AMS teardown will be not today. These tiny screws are doing my head in. It's number 11, Stefan Motor. Hello, LDO, Jason, by the way. Have you been looming in the background? NEMA 11, so it is smaller than NEMA 14, is it? It is very adorable. Look how small it is. So... Right, let's try and get some Hotend close-ups. So, Hotend is obviously two parts. You've got this carriage part. So, this material is a pretty special looking material. It feels quite dense. I assume it's just extremely non-thermally conductive. It looks like a graphite filled plastic thing. I have no idea. It's a fiber filled polymer by the looks of it. It looks kind of like fiberglass actually, like FR4 but really thick. I have no idea. I don't know what the material is, not one I'm familiar with. But it's clearly there to provide thermal insulation between this part, which is your heater, and then you've got this thermistor right down in the tip here. Thermistor, and which is then comes up on this side over here. So this is your thermistor, this kind of coppery part on the front. And then this is what sits in here. There's actually a magnet here which will attract to these two screws when they're installed. And then you put that over there and this over here. And that's then your assembled hot end. So you can see the heater and thermistor wires both go down the base here. Oh, this is a rubbery piece. Can we pull this off? I don't think we want to, just in case. But yeah, you can see, kind of. Can you see down in there? $20 from Jason. Thank you very much, Jason. Yeah, I'm sure where you can see that kind of white stuff, that's going to be part of the like ceramic from the heater, probably. Oh no, is it soft? It's soft. I don't know exactly what's going on there. Let's take it apart and have a closer look. I just saw more screws. If I manage to get this back together, I think that deserves a prize because, quite honestly, this has been a lot of screws. This might be bonded as well. Ooh. The screws are all out. Yeah, it doesn't seem to just lift off. There's 2 screws in here down there where you could potentially remove the thermistor. Probably wouldn't be very easy to replace, but it looks like it could be possible. No, probably not. I don't know why this won't come off. This looks like it should remove. I can't see anything holding that on now, but evidently not going to, so can't disassemble that any further. Right, are there any more requests? Don't turn it on, take it apart. Exactly. Normally I would do that in my live streams, but because I can't do live streams as long as I normally would. Wow, it's 22 hours and 20 minutes. I think I need to stop. Right, let's have a zoom out and see how much mess we've made. Ta-da! That's the A1 Mini. In a way you've never seen it before. Yeah, I don't know how this is all going back together. You want to see the bed belt? It's in there. Oh, I do kind of want to see that mechanism. I can't do more now. Oh, I want to do. Oh, I'm even yawning. Right, we're going to have to stop. Maybe for the reassembly one, we'll do. I think reassembly should typically be faster because I'm not going to be looking at everything as I go. It'd just be screwing stuff together. So I think maybe we'll do it tomorrow even. Is it easy to change the belts? No, probably not. You'd have to find the right pitch and stuff to begin with. I don't know if this is. Oh, this is a really weird belt. This belt only has teeth on half the belt. The teeth don't even go for the full length of the belt. This is full crazy beans. The teeth just stop. Because we don't need teeth on that part, so why bother putting them there? Okay. For drinks when you realise it won't go back together. Brilliant. Thanks very much. We'll try and do some more teardown. So we've got reassembly. Maybe we'll try and do this with that. And then we'll try and take a look at the AMS light as well. I don't think AMS lights are going to have too much involved. But I would like to have a look. So maybe over the next few days, we'll try and get over and done with that. But yes, for now, I have to love you and leave you. Thanks everyone for joining in. Don't forget to leave a like, leave a donation if you're feeling particularly kind, or join as a member. I don't know how many benefits there are. I mean, I've started to do some member live streams. That's one of the plans I wanted to do. So maybe we'll do some more of those on little upgrades and stuff to printers. Or just go and buy stuff at the Vector 3D shop. That's always a great way to support what I've done. If this has been useful or entertaining for you, go buy some stuff from the shop, vector3d.co.uk. Yeah, as Steve says, get yourself a VLMP. Definitely. They're bloody fantastic and they're bloody useful. So, yeah, that's pretty much it. Cheerio, everyone. Thanks very much, and I will see you again rather soon. Goodbye.